So basically what I wanted to do is just kind of give a quick introduction, sort of a high-level perspective on what we see as what we call smart devices or smart field systems, and some of the work I've done in the past has been on things like multi-phase flow metering, which is sort of measuring condensates of oil, gas, and water and things like that, and multi-variable transmitters, which you'll see a lot in some of the chemical and process industries. Intelligent switches, and basically these devices are empowering operational visibility, agility, and flexibility by providing onboard intelligence, programming, analytics, and things like that. And my two speakers are going to provide you some of the futuristic things that we're going to be seeing in the coming years. A little bit about some of the key digital communication networks. Obviously, primarily HART has been the primary digital protocol for most of the process industries, but we're seeing some other ones make emergence. Obviously, Foundation Field Bus, Ethernet IP is actually starting to make a little bit of an entrance with Anderson Hauser and some other companies. So, and obviously we're seeing a slow but a growing emergence of the wireless protocols of wireless HART and primarily ISAE 100, 11A, with other proprietary networks. And basically the bottom line of the value of these different types of systems and networks is the ability to access real-time or near real-time data for real-time monitoring, in some applications control, things like that. But basically taking that data and transforming it into actual information is really where the value is going to be obtained. This is just kind of a quick highlight slide that the 75 million plus installed devices. Our research shows about a little over 2/3 of that right now is what we would consider to be a sort of a smart or intelligent device. As I mentioned before, obviously the two primary ones of those are HART and Field Bus, and there's some other ones that are starting to emerge. But we think that over time, as the business value of these devices is fully maximized and realized, I think that the adoption of the installed base is going to certainly accelerate in the coming years. One problem we're finding is that although there are a fair number of smart devices out there, a large number of these are not being fully utilized, and there's a lot of issues with stranded diagnostics and things like that, and there's a number of different issues that are kind of driving that, and some of them are some technical understanding, it could be cultural, work process flow issues, things like that. But as I'll talk about in a little bit in my presentation, there's a standard in ISAE 108 that's making some strong headway to help address the issue of intelligent device management, which I think is going to make some real traction and really help to get the companies out there to best maximize the use of their smart devices in their operations. And basically, we view intelligent device management as basically risk management. And what I'm going to talk a little bit later on is about things like leak detection. And at this conference, there's been a tremendous amount of great discussion on industrial Internet of Things and cybersecurity and things like that, which are very paramount and critical. But one thing I'd also offer is that issues like physical security, plant infrastructure security and things like that, perimeter security, those things are very critical as well. And I think some of our speakers are going to address those issues in great detail. So I think that it's not just gaining operational efficiencies and increasing production and things like that, but it's also in many cases mitigating risk, to plant assets and obviously for public safety issues and things like that. And here's sort of a quick, as you can read the chart, some of the what are some of the benefits and sort of the return on investment, if you will, of intelligent device management. And I think that there's some that, as we mentioned before, about productivity and workforce efficiencies and collaboration, but also reducing things like unplanned breakdowns, downtime, things like that. So you've got the positive side on increasing revenues and productivity, and also mitigating downtime, which will obviously have an adverse impact on the bottom line and operational efficiency as well. As I mentioned a little bit more, this is kind of a little bit more detail about the ISAE 108 standard. I'm sure most of you probably are familiar with that, but if you haven't, I would recommend that you sort of get more familiar with it. And we had a gentleman here last year, Herman Story, who's sort of heading up part of that, championing that cause, and he had a great presentation, which I recommend you try to access to our website if you haven't already seen it, and talking about a lot of the details of the standard, and it talks about some of the many benefits that will be derived. So I really encourage you guys to consider that if you haven't already done so. But basically, it's sort of a way of getting into work process and maintenance issues and things like that to, again, reduce downtime, enable more proactive or predictive maintenance, asset management, things like that. So it's basically going back to what I talked about before. It's not just, smart devices will provide you the data, but you need to sort of, do something with that data and make it actionable information, and that's really where the rubber meets the road, and where I think that the real material marginal benefits will be derived. Otherwise, you just have a lot of data, and you got to ask yourself, well, is this good data or bad data? So that raises a lot of other issues that need to be addressed. And then, as we talked about, in my mind, I look at industrial Internet of Things is going to be a real revolutionary thing if people fully understand the benefits and deploy them, and obviously address any requisite concerns and issues related to cybersecurity. But I look at smart sensors as kind of being the tip of the spear of basically enabling this all to happen, because you need the sensor data to share and collaborate and do the analytics and things like that. But you need sensor data. You need good quality sensor data. So that's a critical factor in my mind, and it goes back to what they talked about in some of the recent discussions we had over the last day or two about you're only as strong as your weakest link. And I think that this will probably be discussed by one of my speakers here later on about the issue about physical security and cybersecurity and some of the current concerns that companies are having with a sort of a hybrid attack, which is basically a probing perhaps initially by a cybersecurity attack followed up with a physical attack or vice versa. And they certainly pose serious challenges, and the potential implications could be very severe depending on the facility that's being attacked. And basically, this is just kind of some high-level work that I had done on multi-phase flow metering. And as you can see, there's a number of wells out there that are pretty much operational, and they can vary from a couple of barrels a day to tens of thousands of barrels a day, and many of them are being drilled every year due to some of the decline rates that they're finding in the unconventional formations. But basically the benefit of a multi-phase flow meter, particularly on, let's say, an offshore platform, is to minimize the space taken up by a test separator or production separator, and that those are, in many cases, are doing, say, monthly well testing, whereas with a multi-phase flow metering device, you can get daily or even, hourly. You can get it every 6 or 12 hours and things like that. And they're very, very good for enhancing the ability to understand the reservoir with the production flows and its things like that. So there's really some enhanced things that can be done. They're a little bit expensive, and they're basically a multi-sensoral system. They may have 2 or 3 different sensing technologies and a computer system, obviously, to make them all work. And despite that their cost, particularly those in the subsea projects, there's a great benefit. Even at $50 a barrel, there's still significant return on investment that can be realized. And basically, the 2 main types of these type of systems are radioactive systems, which use some kind of gamma ray attenuation or densitometer, and there's also those that offer non-radioactive solutions for certain applications. So it's certainly an area that I thought was pretty interesting. It's still, it's still working. It's still relatively a small segment of the market, but I think it's going to, the adoption rate is going to continue to accelerate, because once the owner-operators and other relevant stakeholders validate the performance of these things, in many cases, it's almost like a no-brainer decision. So once they get validation, and a lot of these companies that offer these systems are actually developing their own testing and validation centers, because they realize that that investment will pay off in much greater multiples down the road. So, and then I'll just wrap up with a little bit of more recent work we did on leak detection, and obviously there's a lot of pipeline out there, particularly in the United States, and that needs some type of There's certainly smart pigs and things like that that'll do pipeline integrity and structural integrity and things like that, but the leak detection solutions are very much an important integral thing, and in many cases in countries like ours and Germany and others, they're mandated by regulatory bodies, so basically you've seen a lot of the press about some of these leaks and ruptures and things like that, and the ability to not only detect a leak but also to localize it more quickly so you can go and get action on repairing and mitigating the damage of the leak is critical, particularly in high consequence areas where you have public or environmental issues that are at stake. Most of the market is comprised of software-based solutions, but as I always said before, you're only as good as your weakest link, and so you have to have high-quality sensor data to work with that, either typically through a SCADA system, or it could be, in the future, there could be more through the cloud and through a smart device that doesn't necessarily need to go through a control system. And some of the ones that we think that will play a big role in the future, and Dave Lafferty will talk a little bit about one on fiber optics, ultrasonic, acoustic, there's Coriolis readers and things like that are also used. And basically the key objectives here is really risk mitigation through faster leak detection and the leak localization. And PHMSA did a study where they basically came right out and said they put actual dollar allocations as to what they thought that an adequate leak detection system would have, and I think it was a couple $100,000 per 300 miles of pipe or something. So for companies that have large pipeline networks, it's certainly an investment that they both mandated in many cases, but also makes good business sense. And then obviously those that have high consequence areas, those solutions are really critical to ensure public safety. So what I just want to wrap up with here is really want to stress that there, in my opinion, and the research we've done, is that there's tremendous value in leveraging smart field devices and smart field systems in the field, and that I think that some of the main issues are work process related, could be cultural, maybe it's a better understanding of somehow how the technologies can be used and be fully maximized. So I think there's some challenges that need to be overcome, but I think that the industry will benefit tremendously by fully utilizing those solutions. And I also want to reiterate the need for not just cybersecurity, that's the hot topic now with Industrial Internet of Things, but also the criticality of obviously physical security, plant asset, security from various intrusion detection, things like that. So.